Welcome back to STS. In today's video, we're going to look at the product rule. Basically stated, when we're talking about a product, we know that means we're taking two quantities and multiplying those quantities together. All right. In this example here, f prime of x is equal to ab. Well, a is a factor and b is a factor. All right. To find the derivative using this product rule, we have to take f prime of x is equal to, we're going to write the first term times the derivative of the second term, plus we're going to write the second term times the derivative of the first term. So let's take a look at an example. Let's say we have g of x is equal to the quantity 2x plus 3x squared times 6x minus 7. Here, let me go ahead and change the color, try to make this a little more distinctive. Here we're saying this first factor here was going to be a, and this second factor here is going to be b. So let's first look at, let's do it over here, a prime. Well, I've got to take the derivative of this first portion here. Well, the derivative of 2x is just 2. And the derivative of 3x squared, I'm going to bring the 2 down, so that's going to give me 2 times 3 to give me 6. And then I'm going to decrement this power of 2 down to 1, so that's going to be 6x. And if I wanted to find the derivative of b, well, 6x, its derivative is just going to be 6. And the derivative of a constant is just 0. So here the derivative of b is just 6. So let's continue with g prime of x. The rule says we write the first term, which is going to be 2x plus 3x squared times the derivative of the second, not term, I said term, I meant factor, times the derivative of the second factor. In this case, that is 6, plus I'm going to write the second factor, which is 6x minus 7, times the derivative of the first factor, and that derivative is here as 2 plus 6x. Now I need to simplify. Here I'm going to distribute a 6 to both terms. So this here is 12x plus 18x squared. And on this one here I need to factor. So I've got 6x times 2 to give me 12x. And then 6x times 6x to give me a 36x squared. A negative 7 times 2 to give me a negative 14. And a negative 7 times this negative 6x to give me a negative 42x. Now I'm looking to combine like terms. I've got a 12x and a 12x. That there gives me a 24x. And then I've got 18x squared and a 36x squared. Well, 8 and 6 is 14. I'm going to carry the 1, so I've got a 1 and 3 to give me 4, plus that extra 1 to give me 5. So that's 54x squared. So those terms gone. And I have a negative 14 and minus a 42x. When I need to do a subtraction, 24x minus 42x, that's going to be negative. And there's actually going to turn out to be 18x. And then I have, let's see, the plus 54x squared, and then the minus 14. And let's put these in the proper order. So 54x squared minus 18x minus 14. So that there would be the derivative of this first example using the product rule. All right, let's take a look at another example. Let's scroll down a bit, and let me go ahead and change color. Let's do this one in a reddish color. All right, for this one, let's say h of x is equal to 4x times 7x squared. And again, I'm going to use the product rule. So this here is going to be a, and this here is b. Well, the derivative of a is just going to be 4. The derivative of b means I bring this 2 down to the front, so I've got 7 times 2 to give me 14, and then I decrement this power, so it's just going to be x. So h prime of x says I write the first term, which is 4x, times the derivative of the second term, which is going to be a 14x, plus I write the second term, which is going to be 7x squared, times the derivative of the first term, which is 4, and then I multiply these out. Well, 14 times 4 is actually 56. X times x is x squared, and then I've got 7 times 4 to give me 28, and I've got my x squared there. All right, I can combine these two terms. 56 plus 28 is actually 84, and I have an x squared. Alright, and I'm going to show this another way. This is using the product rule, but I could have easily I could have easily multiplied these two factors together. So that really would have came out to be 7 times 4 to give me 28. And then x times x squared gives me x to the third. And let's just call this j of x. Well, I could have used the power rule here. So the 3 comes out front, multiply that by the 28, and I have to decrement the x, so that's actually x squared. Well, 3 times 28 is in fact 84x squared. So this here, using the power rule, you see I came out to the same answer by using the product rule. All right, let's do a couple more examples. Go to another page. This example here, let's call this one here g of x. Alright, so g of x is equal to, let's say, 10x squared. Alright, we're going to say 10 is a, and we're going to make the x squared b. Well, the derivative of a is 0, because 10 is a constant. The derivative of any constant is just 0. And now we'll take the derivative of x squared. Well, that's going to actually be 2x. Right, now the derivative of g of x, I write the first term, which is 10. I take the derivative of I keep saying term, but I mean factor. The derivative of the second factor is 2x. I'm going to add that to where I now write the second factor, which is x squared, and I'm going to multiply that by the derivative of the first factor, which here is 0. So I have 10 times 2 to give me 20, and I've got an x, and then plus x squared times 0, which is just 0. So here I have the answer of 20x. And if I were to go back and use the power rule and the constant multiple rule, I would have a 10 coming out front that I would not take the derivative of. I would use the power rule on the x squared, which means a 2 comes down, and then I decrement this power of 2 to just a 1. So 10 times 2 to give me 20, and I'm still left with the x. So I get the same answer. Where here I use the constant multiple rule as well as the power rule. And let's go ahead and do one more example. Next example, let's call this one here k of x, and actually let me change the color so these don't blend in. Let's go to purple, and let's say this one here is a reciprocal function where I have 4 over x, but also note that this can be rewritten using negative exponents where I have 4 times the times x raised to the negative 1. And then here you see that I can now use again the constant multiple rule and also the power rule, but I am going to stick with the product rule. So here we see that the 4 is my factor that I'm going to substitute as a, and then x raised to the negative 1 is my second factor that I'm going to call b. Well, a prime, whenever I take the derivative of a constant, that's just 0. And now for b prime, I'm going to use the power rule. So this negative 1 comes out front, and what I end up doing is actually decrementing. So this here is actually negative 1 minus 1, which turns this into negative x raised to the negative 2, which is really negative 1 over x to the positive 2. All right, now with the one second here. Now with the product rule, I'm going to write the a factor, and I'm going to multiply that by the derivative of the b factor. In this case is negative 1 over x squared plus, now I'm going to write the b factor, which is x to the negative 1, and I'm going to multiply that by the derivative of a, which is in fact 0. And now I've got negative 4 over x squared, and 0 times that is just 0, so I won't write that. So here the derivative turns out to be negative 4 over x squared. And if I were to use the constant, the constant multiple and the power rule, I've got 4 times x raised to the negative 1. If I bring the negative 1 down to the front, I've got negative 1 times 4x, and now I need to decrement this negative 1, so that's really going to be negative 1 minus 1. So negative 1 times 4 to give me negative 4, and then I've got x raised to the negative 2. To write this with positive exponents, my numerator is negative 4, and then my denominator becomes x raised to the second power, and we see that both of these are the same. Alright, so that sums it up for this video by Speller Tutorial Services. Please friend us on Facebook and also subscribe to that YouTube channel so you can be made aware of all the new videos and any updates on our channel. And as always, thank you for watching.